Hello, my name is Dave Bratt, and today I want to check out microphones. The way a microphone sounds when you pick it up, check 1, 2.
Hey, 1, 2.
You can hear the various
2, 2, 2. Hey.
Each mic has got its own sonic characteristics, but there's more to a mic than the way that it sounds. There are two other primary characteristics which I believe should be taken into account when you're selecting the microphone for the artist or application. One of those is pickup pattern. How well does the mic reject behind it, or where are the rejection what is the shape of the rejection pattern? How much rejection do you get? So it's not only the shape, but how effective it is. And secondly is the distance from the mic. What is the variation in level based on the distance from the source to the mic? I'm going to try and demonstrate both of those things here with this setup. It's pretty simple. I've got a couple microphones, some other mics to test, a little mixing board, 2 inputs. It comes out of the mixing board into this analyzer here, as you can see. It also comes out of the mixing board into the amplifier, driving the speaker so we can listen to what's going on. And then I've set up a pair of little iPod headphones into a pink noise source. So this gives us like a little point source that will allow us to hear what's going on. And it should be pretty simple. And as you can see, there we're in the front. I'm going to try and get these to the same volume. If I talk, 2 LEDs below the line. Close enough. Okay, so now we'll check the rejection patterns of these mics. As they come around the side, you get fading off. On the side it's lower. Coming around back, it picks up again. Alright, now we'll check the Audix mic around front. Alright, coming around the side. Notice how quickly it drops off. It's almost, we're still very close to the front of the mic, but we've lost a significant amount of volume. And coming around the side. Significantly lower around the sides. And coming around back. We can't even see it on the analyzer. This amount of rejection in the back is useful for reducing the amount of room noise that comes into the mic in ratio to the front of the mic. So if you have 2 people, if you sing exactly the same volume into both mics, the percentage of room sound that you're going to get is going to be lower on the Audix mic than it would on the Shure mic sound. Okay, so now let's look at distance versus volume. So I'll use my complex measurement system of 3 fingers, and here we're about 1 LED over the white line, 2 LEDs over the white line, 3 fingers out. I'm 1 LED under the white line there. Okay, here 2 LEDs under the white line, 3 fingers out. I'm 2 LEDs over the white line. Alright, so each LED is about 2 dB. There's about a 3 LED difference. That's about 6 dB difference. That's a significant change. That's 4 times the amount of voltage, or 4 times the amount of volume. How about we take a look at, here's a Neumann KMS105. Mics down. Now, this mic is a condenser mic. Alright, so try and match levels. Close enough. Alright, what's interesting about the Neumann is it goes even further. Look at that. Off to the side of the pickup pattern, it almost sounds the same as it does in front. It really has tolerance to singing off center on the mic, and as you back away from the mic, it really doesn't lose. It only loses about 2 to 3 dB, 2 to 4 dB as you get to that distance. So the asset is you get the room sound, you get the ability to work the mic. It's very tolerant for performer motion. Coming around back though, significant pickup behind the mic. So it's not going to be very tolerant towards high level monitoring where you have actual wedges. And ringing it out, and it's going to want a feedback. What else do we got? How about a Sennheiser 835? Bring that up to a level. Alright. These are, see how it's starting to drop off around the side? Coming around the side. And lower volume. Alright, so that's somewhere between the Audix and the Shure. It's, oh, checking distance. Remember the Audix was below this white line. And this is above. So what we're seeing with the Sennheiser is that it's more directional than the Shure. It's got better rejection behind it than the Shure had. And it's a little more tolerant to distance. So it's somewhere in between the two. If you have a performer that backs off the mic a little bit, and you want some more rejection, and you want a little less room sound, Sennheiser 835 is an excellent choice for that. Let's do one more. Here's the Audix om7. Now this appears to be a little more tolerant than the om7. We're not dropping off quite as quickly as we bring the source around the side. Yet we still have the rejection behind. Alright, that's it. Selecting the right microphone for the application. It really depends on the performer. If you have a performer that's going to sing at a distance from the mic and they'll be off axis of the mic, you want to lean more towards the condenser side. These Neumanns are great. I didn't test it here, but the Sennheiser 865 is another great one that's not as wide of a pattern as the Neumann, but definitely open, and it'll give the performer some room to move around. The downside is if you have high volume monitors, it's going to be tough to ring them out. You're going to get a lot more room sound. And the Audix om7 is a little bit even farther than that. It's got even more rejection behind it. It's even less tolerant to backing off the mic, and then all the way at the other end of this, at that end of the spectrum, is the om7, which is the least tolerant to backing off the mic. It's got the most rejection. You're going to get the most gain before feedback in monitor systems, and the least amount of room sound. Whether that's preferable or not for your application or needed, that's what you get to decide, but hopefully this information is helpful.